Hey there, science fans! Welcome back to another deep dive into the world of energy and innovation. Today we're going to explore a different kind of nuclear power, one that could completely transform the way we think about energy and maybe even change the world as we know it. Our story begins with a little-known element called thorium. It might not be a household name, but it has some truly remarkable properties. You might be wondering, thorium? What's that and why should we care? Well, hold on to your lab coats, because thorium could be the secret ingredient to a cleaner, safer, and more sustainable energy future for everyone on the planet. Thorium is a naturally occurring radioactive element found in rocks all over the world. In fact, it's much more abundant than you might think. It's actually more common than uranium, which is the fuel used in most nuclear reactors today. That means we have a lot more of it available for potential use. But here's the catch: thorium itself can't be used directly as nuclear fuel. It needs a little help, a bit of nuclear magic, to unlock its true potential. Through a special process, thorium can be transformed into a powerful fuel that could drive the next generation of nuclear reactors. Now you might be thinking, nuclear power, isn't that dangerous? What about all those scary stories we've heard? And you're absolutely right to be cautious. Traditional uranium reactors do come with significant risks, including the potential for meltdowns and the problem of long-lived radioactive waste. But thorium reactors are a whole new ballgame. They operate differently, with built-in safety features that make them much less likely to have catastrophic failures. Plus, they produce far less radioactive waste, and the waste they do create is much less dangerous over time. This could solve one of the biggest challenges facing nuclear energy today. So, buckle up as we dive into the fascinating world of thorium reactors, and discover how this innovative technology could revolutionize the way we power our planet, making energy cleaner, safer, and more sustainable for generations to come. Okay, science sleuths, let's break down the fascinating journey from humble thorium to powerful nuclear fuel. This process is a marvel of modern science, and it all starts with a simple mineral that holds incredible potential. Imagine it as a real-life alchemy experiment, except instead of turning lead into gold, we're transforming thorium into a very special kind of uranium, known as uranium-233. This transformation is at the heart of next-generation nuclear technology. Here's how it works. Inside a nuclear reactor, thorium is exposed to a steady stream of neutrons, which are essential for the reaction to take place. Think of neutrons like tiny, invisible subatomic bullets, zipping around at incredible speeds, searching for atoms to collide with. When one of these neutrons strikes a thorium atom, it triggers a remarkable chain reaction, setting off a cascade of atomic changes. Through this reaction, the thorium is gradually converted into uranium-233, which is the nuclear fuel we're after. This fuel is highly sought after for its efficiency and potential for cleaner energy. But the process doesn't stop there. There's more science magic at work. The newly created uranium-233 is also radioactive, meaning it's unstable and ready to release energy. When this uranium is hit by more neutrons, it splits apart in a process called fission, unleashing a tremendous amount of energy. This is the energy that lights up our homes, powers our cities, and keeps our modern world running. The beauty of this process is that it's self-sustaining. Once it gets going, it can keep running with minimal input. As the reaction continues, it not only generates more energy but also produces more fuel, making it an incredibly efficient and promising way to meet our growing energy needs. Talk about a scientific breakthrough. Now let's take a closer look inside the heart of a thorium reactor, a place where science and engineering come together in a truly remarkable way. We're about to discover how this innovative technology actually works, and why it's so different from what you might expect. Unlike traditional nuclear reactors, which rely on solid fuel rods packed with uranium or plutonium, thorium reactors use something quite fascinating: molten salt. Imagine a swirling pool of molten salt, glowing with heat and energy, heated to incredibly high temperatures, sometimes over 700 degrees Celsius. This molten salt isn't just a coolant, it also acts as the carrier for the thorium fuel, dissolving it right into the liquid. It's like a nuclear soup, constantly circulating through the reactor core, ensuring an even distribution of heat and fuel. As the thorium fuel in the molten salt undergoes fission, it releases a tremendous amount of heat energy, which is carefully monitored and controlled. This heat is then transferred to a separate loop of molten salt, which acts as a bridge to heat water and create steam, without mixing with the radioactive materials. The steam produced drives massive turbines, generating electricity for homes and industries, just like in a conventional power plant, but with a modern twist. This molten salt design offers some significant advantages over older technologies, making it a promising option for the future of clean energy. First, it allows for continuous refueling, so the reactor doesn't need to be shut down for maintenance as often, increasing efficiency and uptime. And second, it operates at much higher temperatures than traditional reactors, which means it can convert more heat into electricity, making it far more efficient and potentially safer as well. So, how does thorium stack up against uranium, the current heavyweight champ of nuclear power? Well, it turns out that thorium has a few tricks up its sleeve. First off, thorium is much more abundant in nature than uranium. In fact, it's estimated that there's enough thorium on Earth to power our planet for thousands of years. That's a lot of potential energy just waiting to be unlocked. Second, thorium reactors produce significantly less radioactive waste than uranium reactors. The waste they do produce is also less dangerous and decays much faster. That means less of a headache when it comes to long-term storage. Finally, thorium reactors are inherently safer than their uranium counterparts. The molten salt design makes it virtually impossible for a meltdown to occur. Plus, the thorium fuel cycle doesn't produce plutonium, a key ingredient in nuclear weapons. Let's talk safety, folks. When it comes to nuclear power, safety is always the #1 concern, and that's where thorium reactors really shine. Remember that molten salt we talked about? It plays a crucial role in making thorium reactors incredibly safe. If the reactor starts to overheat, the molten salt automatically expands, slowing down the nuclear reaction and preventing a meltdown. It's like a built-in safety valve. Another safety advantage is that thorium reactors operate at atmospheric pressure. That means there's no need for those massive containment structures you see at traditional nuclear power plants. This makes thorium reactors simpler, cheaper, and less vulnerable to accidents. And let's not forget about the waste. Thorium reactors produce a fraction of the radioactive waste generated by uranium reactors. The waste they do produce is also less hazardous and decays much faster. That's good news for the environment and future generations. Now let's address the elephant in the room when it comes to nuclear technology, the risk of weapons proliferation. The good news is that thorium reactors are inherently proliferation resistant. You see, the uranium-233 produced in a thorium reactor is always contaminated with uranium-232, a highly radioactive isotope. This contamination makes it extremely difficult and dangerous to extract and purify uranium-233 for weapons use. Think of it this way. Trying to extract weapons-grade material from a thorium reactor would be like trying to steal candy from a baby that's also a very angry porcupine. Not a good idea. So, by choosing thorium over uranium, we can enjoy the benefits of nuclear power while minimizing the risk of contributing to the spread of nuclear weapons. It's a win-win for global security. Now let's shift gears and talk about why China is so gung-ho about thorium. One word: resources. China sits on a massive reserve of thorium. In fact, it's estimated to hold about a third of the world's total supply. But here's the thing. China isn't just rich in thorium, it's also a leading producer of rare earth elements. These elements are essential for many high-tech industries, including renewable energy technologies. And guess what? Thorium mining often goes hand in hand with rare earth extraction. So by developing thorium reactors, China can kill two birds with one stone, secure a long-term energy source, and consolidate its dominance in the global rare earth market. Talk about a strategic advantage. China isn't just talking about thorium power, it's putting its money where its mouth is. In recent years, China has made significant strides in thorium reactor research and development. In 2021, China made headlines when it successfully powered up an experimental thorium reactor in the Gobi Desert. This marked a major milestone in the development of this promising technology. While still in its early stages, this experimental reactor serves as a valuable testing ground for China's thorium ambitions. But China isn't stopping there. It has ambitious plans to build a larger, commercially viable thorium reactor by 2030. If successful, this would be a game-changer, paving the way for the widespread adoption of thorium power both in China and around the world. China's interest in thorium goes beyond just energy security. It's also a key part of the country's strategy to combat climate change and transition to a cleaner energy future. China is the world's largest emitter of greenhouse gases. The country is facing mounting pressure to reduce its carbon footprint and clean up its act. Thorium, as a carbon-free energy source, offers a promising solution. By investing heavily in thorium technology, China is betting big on the future of clean energy. If this gamble pays off, it could position China as a global leader in the fight against climate change. And that's something the whole world can get behind. So there you have it, science fans. Thorium reactors offer a tantalizing glimpse into a future where nuclear power is safer, cleaner, and more sustainable. With its abundance, inherent safety features, and reduced waste, thorium has the potential to revolutionize the way we power our world. China, with its vast thorium reserves and ambitious research program, is leading the charge in this thorium revolution. If successful, China's efforts could pave the way for a global shift towards thorium power, ushering in a new era of clean and sustainable energy production. While there are still challenges to overcome, the promise of thorium is simply too great to ignore. As we continue to explore the frontiers of science and technology, thorium stands out as a beacon of hope, a testament to our ingenuity and our unwavering pursuit of a brighter future.